Hey guys, so if you're here with me, it's because you are getting the play-by-play for each of these questions in the first column, 1 to 14. So let's get started. Number 1 is, I'm trying to get this. No. There we go. Number 1 is a basic order of operations question where when they give you 3 times 4 to the third, you have to do exponents first. So there'd be 3 times 4 times 4 times 4. And you could just do that in your calculator. 12 times 16, that's going to give you 192. So that's how that happens. In number 2, the premise behind this question is the fact that you are multiplying 2 different terms that have like bases. So when you're doing this, you want to multiply the coefficient. So you're literally going to do 4 times 2, which is 8. But you keep the base and then you add the exponents so that you end up with 8x to the 6th. That's the answer for number 2. And that's how you get it. You keep the base and add the exponents up. Number 3 is a like base question as well. When you're multiplying, you are going to keep the base and add the exponents. So this is going to be x to the 8th. Number 4, again, this is the same premise as number 2. 2x to the third times 2x squared. You're going to multiply the coefficients, so you're going to end up with 4. You're going to keep the base, and you're going to add the exponents up. So this would be 4x to the 5th. Number 5. This is a question where I want to show you something because this is a calculator question, but not really. You don't really need a calculator for this. When you're dividing with exponents with the same base, you can keep the base and subtract the exponents. That's going to give you 6 to the 2nd power, and we don't need a calculator for that. That's just going to be 36. So same base, just subtract your exponents when you're dividing. Number 6, same premise. We're going to talk about that a little bit. This is same base. We're going to subtract the exponents. So it would be x to the 4 minus 7. So that's x to the negative 3. Now, with a negative exponent, what that literally means is that it needs to change position from the numerator to the denominator. So right now it's in the numerator because I can put this over 1. So what's going to happen is I'm going to shift this term with a negative exponent into the denominator and turn it to a positive exponent. So that's going to make x to the 3rd on the bottom and a 1 on top. And that's because there's really truly a 1 out in front of this x to the negative 3. So again, same base, you're going to subtract your exponents. That leads you to a negative exponent. And then to deal with a negative exponent, you're literally going to switch positions. So if you're in a numerator, you're going to go into the denominator with a positive exponent. And this is your final answer. Number 7, 8 to the 0 power. Many kids don't realize that anything, any term, any length of term raised to the 0 power is the whole number 1. So that's a basic rule, but that's a real easy rule to forget, but it's also a really easy rule to remember. So commit it to your memory. That's a good one. Number 8 is a negative parenthesis 9x to the 0. So the first thing you need to do is remember that we need to do order of operations. Order of operations says that you're going to do the exponent first. So that means we're going to have a negative, and then all of this raised to the 0 power is 1. So your answer is negative 1. Number 9, you have y to the fourth, all raised to the third. And when you raise a power to a power, what that means is that you're going to multiply these together. So that's the same as saying y to the fourth times y to the fourth times y to the fourth. And you know, when you multiply, you're adding these. It's just continuing adding the same term, or you just do 4 times 3. And 4 times 3 is 12. So your answer would be y to the 12th. So you can either multiply these or expand them out and add them, but either way you should get y to the 12th for your final answer. Number 10, you have x squared y, all raised to the fourth. And what you have to remember is that these two terms are being multiplied on the inside, which means what you're going to do is you're going to take this first one and do x squared to the fourth. And then you're going to do y to the fourth. You're literally going to give each piece a to the fourth power. Remember that a power to a power, you're going to multiply. So this gives you x to the eighth. And this is just y to the fourth all together. Number 11 is a division problem where you've got 6x to the seventh over 2x to the fourth. So when these have coefficients that are different, you are going to divide these. You're going to divide those, and that becomes the whole number 3. You are then going to keep the same base and subtract these exponents, because when you're dividing with the same base, you subtract exponents. So 7 minus 4 is 3. So this is going to be 3x to the third. We only got a couple left in this column. Get to a new page. Number 12. You have 8x to the fifth over 4x squared. Same premise as number 11. You are going to divide out your coefficients. So you're going to end up with 2. You're going to keep the same base, and you're going to subtract the exponent. So this is going to be 2x to the third. 13 is a big one. 13 is a big one. You've got 2cd to the fourth, all raised to the second power, times cd, all raised to the fifth power. So the first thing you need to know is that all of these terms on the inside of the parenthesis are being multiplied. So this is a 2 times a c times a d to the fourth, and all of those are being squared. That means that every single one of these needs to be squared. So this is going to look like 2 squared, c squared, and d to the fourth squared. That's how you break this down. Everybody gets a squared term there. And then these are also being multiplied here. So this is going to give me c to the fifth and d to the fifth. Now it's my turn to start simplifying these. So I have 2 squared is 4. This is just c squared. This is d to the 8, because a power to a power you multiply. And then another c to the fifth, and then a d to the fifth. And the last thing you're going to do is you're going to combine your c's, because you have the same base. You're going to add those exponents. That's going to give you c to the seventh. You've got the d's here. That's d to the eighth and d to the fifth. You're going to keep the base and add those. That's going to give you 13. And you're going to bring that 4 down. So your final answer is 4c to the 7th and d to the 13th. Last one in this column. Another big one. 2f g to the 4th, all raised to the 4th, times f g, all raised to the 6th. So again, we're going to use the same premise that this is 2 times f times g to the 4th, all raised to the 4th. So that means that each piece gets a 4th power. 2 is going to go to the 4th. F is going to go to the 4th. And g is going to go, or g to the 4th is going to go to the 4th. And that's because these are all being multiplied. That's the only reason why you can distribute that exponent. The same thing goes here. This is f times g, so we're going to have f. Oh, did that wrong. I'll make that a 6. F to the 6th, and then g to the 6th. Okay, it's a wacky looking 6, but that's still a 6. Okay, so now we are going to simplify this. 2 to the 4th is 2 times 2 times 2 times 2, so that's 16. That's f to the 4th times g to the 16th, because you're multiplying power to power. Then you've got another f to the 6th and another g to the 6th. Last step, you need to keep your same base, and you're going to add your exponents. So you've got f to the 4th and f to the 6th. That's going to give you an f to the 10th. And then you have g to the 16 and g to the 6th. And you're going to add those up, and you're going to get g to the 22. That's your final answer for 1 to 14. Contact your teacher if you have any further questions.